Cauchy Euler 8-8, and this is going to be a very quick video because this is actually just it's more bullshit, really. You just have to know what the hell you need to do. And yeah, these differential equations are really plug and chug. And so, what are Cauchy Euler equations? They have this following form. Cauchy Euler equations. You'll spot them immediately, but they're going to have x squared y double prime minus, and then now like something x, right? So let's say ax y prime, and then minus or like plus ax y prime plus by is equal to 0. Okay, so we're just going to deal with the homogeneous case first. I'm not going to deal with the right hand side being something that's different from 0. And the reason why I'm not going to deal with that in this video is because I'll cover it after I cover reduction of order, which is the next video I'm going to do, because when you run into that case, you actually have a lot of things you can do. There are actually two main options, and it actually gets kind of messy as well. So let's stick with this for right now. And okay, so you get one of these equations. So for example, all right, and of course it doesn't just have to be y double prime. It could be like y triple prime. You get the idea, but this leading term has to be x squared, and then you essentially have to have like a polynomial or something that looks like a polynomial. So anyhow, this is going to be the form you see it most often. So how do you solve these problems? Well, consider this following problem then. If you have x squared y double prime minus xy prime plus 5y equals 0, right? It has this form as it above, right? So b is 5, and so that's a b, not a 6, and then a looks like -1. All right, and what do I do? Well, you essentially say that y is equal to x to the r. Okay, so what happens when you say y is equal to x to the r? Well, y prime becomes rx to the r minus 1, right? And y double prime becomes r times r minus 1 x to the r minus 2. And then you plug it into the original equation, and what do you get? Well, you get x squared times r minus 1 x to the r minus 2, right? Minus x times r x to the r minus 1 plus 5x to the r is equal to 0, right? And now what? Oh, you'll see that, oh, this actually works out really cool because this is now r minus 1 x to the r minus r x to the r plus 5x to the r. And you'll realize that x to the r can never be 0. So now we just have to solve for these coefficients, right? So now you can divide by x to the r, and you get r times r minus 1 minus r plus 5 is equal to 0. So this is r squared minus r plus 5 is equal to 0. You get r squared is r squared minus 2r plus 5 is equal to 0. And now you see r is equal to 2 plus or minus the square root of 4 minus 20. I always say 16 because I know what the answer is. It's going to be 16. It's going to be a root 16 under there. And then so this is 1 plus or minus 2i. Okay? And so now the r is equal to 1 plus or minus 2i. Okay, cool. And you might be wondering, did I have to really show like these steps here? And no, you can literally just go from here. You can go from this step to this step. You could go from the first step to that step. You can literally just replace you can replace this first term with r times r minus 1, and then the second term Be careful because if there's a coefficient here, you need to have that coefficient here as well. But anyhow, yeah, you can just literally go from that step to that step, replacing essentially x squared y double prime. Right. Essentially, what happens is x squared y double prime is equal to r times r minus 1, and then x y prime is equal to r, and so and then y just disappears, right? If you're just left with a 5. So yeah, like that's all this is. So now you have r is equal to 1 plus or minus 2i. So how do I write a solution for that? Well, it's actually simpler than you think. In your textbook, if my computer will follow along nicely, it's not. Here we go. In your textbook, it literally tells you what to do. So look, I have a complex conjugate root. Right? I have a complex conjugate root, so y1 is equal to, wrong color, y1 is equal to x to the a, and in my case a is 1, so x cosine x to the 1 cosine b ln x, which is b is 2, so 2 ln x, and then y2 is x sine 2 ln x. All right, and then therefore my general solution is y is equal to c1x cosine 2 ln x plus c2x sine 2 ln x. Okay, and yeah, there we go. You're done. And yeah, that's all Cauchy Euler is. You just follow this table. You make this weird ass substitution that seems to come out of nowhere, and you follow this table in the textbook on page. What page is this? It's not 569. Okay, please. I don't know what page of the textbook it is, but it's where example 882 is. You see that? So that's the page of the textbook.